1:04 in the afternoon, the control room at BP's Texas City refinery showed 7.9 feet of liquid inside a distillation tower. The real level was 158 feet, only 12 feet from the top. 16 minutes later, a vapor cloud ignited. 15 workers died, 180 were injured, and losses exceeded $1.5 billion. The disaster did not begin with the explosion. It began with a machine reporting that a nearly full tower was almost empty, and a system with no reliable way to challenge it. The vessel was a 170-foot raffinate splitter, a distillation tower used to separate hydrocarbon mixtures. During startup, the written procedure called for about 6.5 feet of liquid at the bottom, but the level transmitter did not measure the whole tower. Its useful span covered only about 5 feet within the bottom 9 feet. Once liquid rose above that narrow window, operators had no continuous measure of the true height. A separate high-level alarm should have provided a second warning. It did not activate. A sight glass could have offered visual confirmation. It was dirty and unreadable. On March 23rd, feed entered the tower while too little liquid was leaving it. The mismatch stayed hidden behind a reassuring display. At 11:16, the instrument suggested about 8.7 feet. The real level was 67 feet. At 11:50, the display fell to 8.4 feet while the tower reached 98. At 12:42, it showed 8 feet. The liquid stood at 140. Then, at 1:04, the screen declined again to 7.9 feet. Inside the tower, the level had reached 158. Heating expanded the trapped liquid until it filled the column and spilled into the overhead piping. At about 1:14, the rising liquid opened all 3 pressure relief valves. Their job was to protect the tower from rupture, but they discharged into an undersized blowdown drum connected to a 113-foot stack open to the atmosphere. The drum rapidly filled. Liquid hydrocarbon erupted from the top like a geyser, fell through the air, and evaporated into a flammable cloud near the ground. This disposal system dated from the 1950s. It had never been connected to a flare, a safer system that could contain liquids and burn hazardous vapor before it spread through the refinery. Wind carried the vapor through pipe racks, vehicles, and occupied work areas. The Chemical Safety Board identified an idling diesel pickup, parked about 25 feet from the blowdown drum, as the most likely ignition source. At 1:20:04, the cloud exploded. Temporary contractor trailers had been placed as close as 121 feet from the release. All 15 people killed were contractors working in or around those trailers. 180 more people were injured. The final report did not describe one bad decision. It described layers of defense that had disappeared. Known instrument problems were left unresolved. Startup procedures did not match actual practice. Abnormal startups had become normal. Of 19 recent startups, only one kept both level and pressure within the intended limits, yet the earlier events were not investigated as warnings. There was no automatic high-level shutdown, no reliable full height measurement, no flare and no safe distance between the hazard and the trailers. A safe system is not a perfect operator watching a perfect gauge. It is a set of independent protections that still work when the gauge lies. At Texas City, nearly every layer failed before the first flame appeared.